Problem number 16 is asking us to graph some trig functions. The first thing I always do when I'm graphing trig functions is list out my shifts or my changes to my functions. So my amplitude here is going to be 1/2. That comes from my A. My orientation is positive. And I have a horizontal shift or a phase shift that is to the right by 60 degrees. So now I'm going to label my axes. On my y-axis, I'm going to go by halves. Actually, I'm going to go by quarters so that I can use up some of this space because I only have an amplitude of 1/2. So I want to have some space. Instead of getting a tiny little wave down here, let's actually utilize some of this space. And then on my x-axis, I'm going to have to shift by 60. So on my x-axis, I'm going to go by 30s. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, 390, 420, and so on. I like to deal with changing my amplitude first. And once I know what my function somewhat looks like, then I will deal with my horizontal shift. I know that a cosine function starts on my x-axis at positive of my amplitude, since this is positively oriented. Therefore, I know it's going to start at positive 1/2. And one full cycle goes from 0 to 360 degrees, and it ends also at a peak. Halfway in between the start and the end of one full cycle, directly in the middle, or at 180 degrees in this case, I go to a minimum. Therefore, I'm going to be down at negative 1/2. And halfway between a starting point and a middle point, kind of like a quarter point, a quarter of the way. So at 90 degrees, I'm going to cross the x-axis. Therefore, I have a point at 90 degrees and at 0, at 270 degrees and 0. So I have the basic shape of my cosine function. But now I need to shift this function. This function has to get shifted to the right by 60 degrees. That tells me that each of these points has to move to the right by 60. This first point is going right by 60 degrees to 60 degrees. And this point at 90 degrees is going right 60 degrees to 150. My 180 point is going right by 60 degrees to 240. My 270 point is going right 60 degrees to 330. And then my point at 360 goes right 60 degrees to 420. And then I can go through and draw in my graph. Notice how I used a dashed line to identify my original function. That's not my final answer, but this solid one is the graph of this cosine function. Part B wants us to graph -3 sine of x plus 1. So again, let's list out what's happening. We have an amplitude of 3. Remember, amplitude is always positive. Our orientation is negative. Therefore, we're going to be going down first instead of up. There is no horizontal shift in this graph, but we do have a vertical shift. Our vertical shift is up by 1 unit. On my y-axis, I'm going to go by ones. And on my x-axis, I am going to go by pi over 6. So pi over 6, pi over 3. You're just adding fractions. Pi over 2. 5 pi over 6. Excuse me, not 5 pi over 6, 2 pi over 3. Five pi over 6, pi, 7 pi over 6, 4 pi over 3. And essentially all I'm doing is I'm adding pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6, but 2 pi over 6 reduces 2 pi over 3. Then I'm going to 3 pi over 6, which simplifies to pi over 2. 4 pi over 6 simplifies to 2 pi over 3. 5 pi over 6, 6 pi over 6 simplifies to pi, and so on. And 12 pi over 6 gets us to 2 pi. Now this is a sine function and it's negative. Remember that sine functions start going down, or excuse me, start at the origin. So I know I'm going to start at the origin and I'm going to end on the x-axis out at 2 pi, because one full cycle of the sine function goes from 0 to 2 pi, and it starts on the x-axis and ends on the x-axis. Actually, it starts on the midline and ends on the midline, but I'm going to deal with that vertical shift after I have what my function is looking like. With our sine function halfway between 0 and 2 pi, which happens to be pi, you get another x-intercept. And since this orientation is negative, instead of going up first, we're going to go down first. Therefore, halfway in between 0 and pi, at pi over 2, we're going down to negative 3, since our amplitude is 3. And halfway between pi and 2 pi, at 3 pi over 2, we're going to go up to positive 3. So without any horizontal or vertical shifts, just changing the amplitude and the orientation, that is what our sine function would look like. Now, since our vertical shift is up 1 unit, we're going to move each point up 1 unit. And that will give us our final graph. And then part C. Part C wants us to graph y is equal to 4 cosine of x plus pi over 2 minus 2. Well, our amplitude in this case happens to be 4, since our A is 4. Our orientation is positive. Horizontal shift. That's given by our h. It's going to the left by pi over 2, since this is negative pi over 2. Remember, this is saying x minus negative pi over 2, but they rewrite it with a positive. So we're going left by pi over 2. And our vertical shift, we are going to go down 2 units. I'm going to use 1s on my y-axis. And on my x-axis, I'm going to go by pi over 6. I could go by something else, but I want to use up good space. So pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6 is pi, and so on. And then in the negative direction, negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3. Okay. So I'm going to draw my shape with my amplitude. This is a cosine function. Cosine functions start at either a maximum or a minimum on the y-axis. And so since the amplitude is 4, I'm going to start up at positive 4, and then they have a cycle of 2 pi. So they end at 2 pi up at positive 4 also. Halfway in between, or at pi, we go down to a minimum, negative 4. And then halfway in between a maximum and minimum, at pi over 2 and at 3 pi over 2, we get our 0 values. Then we can deal with our horizontal and vertical shift. Our horizontal shift is left by pi over 2. I'm going to take each of these points, and pi over 2 happens to be 3 lines on my graph. I'm going to move everything over 3 lines. And that gives me my graph with my horizontal shift. And then I need to also take into consideration my vertical shift, down 2. Therefore, I'm going to take each of these points that I just moved and move them down 2. I get a point here, and a point here, point down here, here, and here. And then I can draw my smooth curve through these points. It's often easier to take all of these shifts in pieces than to try to do all of it at once. And if you notice, we shifted by 90 degrees. This happens to be a sine function. And that comes from the fact that sine and cosine differ by a value of pi over 2 or 90 degrees.